So I'm Ross Pickering and I'm a third year geography student, and today I'm going to be talking about the problems caused by an increasing greenhouse gases on urban transport. So most people agree that global warming is the most controversial issue in the 21st century for science and society. Maslin 2011 suggests that this is because global warming is caused by a massive increase in greenhouse gases such as carbon dioxide. Chapman 2007 notes that the transport sector accounts for 26% of global carbon dioxide emissions. Road use, railways and aviation are the key areas affected by increasing greenhouse gases. This causes many complex and varying problems. Hooper and Chapman 2012 argue that the increasing fluctuations in temperature will result in an increasing number of hot days and a decreasing number of cold days. Consequently, more hot weather will cause greater melting of tarmac on roads and the potential for buckling on railway lines. This problem has the capacity to increase travel delays as well as temporary and permanent closures of local and national transport systems. Increased heat will also cause exhaustion and less productivity for staff working in the transport and infrastructure sectors. Furthermore, at the opposite extreme, if cold days decrease, there will be winter maintenance caused by below freezing precipitation levels and freeze thaw. This would reduce delays and temporary closures of urban infrastructure. Overall, changing temperatures caused by an increase in greenhouse gases on urban transport has a significant impact. The effects of increasing precipitation on urban infrastructure have been frequently discussed in the carbon management literature. Huey and Nixon 2008 and Jarotsky, Hooper and Chapman 2014 analysed the effects of adverse weather conditions on road users. In particular, are there an increase in the number of road traffic collisions as a consequence of more frequent precipitation extremes? Adverse weather conditions can also cause landslides, which are problems for both road, rail and also tram networks. For example, see Lloyd et al. 2001 for more analysis on this issue. Meanwhile, Jarotsky, Hooper and Chapman 2014 argue that increasing GHGs will result in greater potential of flooding in urban areas. Bearing in mind urban areas have more impermeable surfaces than rural areas, this will exacerbate problems for urban infrastructure induced from climate change. Impermeable surfaces are unable to penetrate water, which has overflowed from coasts and rivers, which therefore increases the potential for flooding to occur. These drastically affect transport as many road and rail systems and also cycling networks pass adjacent or near coastline and rivers. For example, locally in Oxford, United Kingdom, if the River Thames flooded at Oseley Island, this could have major social, economic and environmental implications for transport routes along Botley Road and also at the nearby Oxford railway station. This would cause widespread disruption for many transport systems, which demonstrates the severity of increasing greenhouse gases or GHGs on urban infrastructure. Finally, the financial implications of increasing greenhouse gases on transport infrastructure in urban areas is substantial. The European Commission 2012 argues that the greatest cost of damage to infrastructure as a result of extreme events, although Gillette and Gokakis 2018 suggest that the economic impact of climate change on transport is most felt with regards to adaptation. For example, extensive drainage systems for road and rail transport could cost up to 130 million from the research that Altvater et al. 2012 found. Now, one of the questions you might have would be who would be responsible for paying for these maintenance costs, and this remains to be seen. This is why greater empirical discussion is required to understand the severity of the problems caused by increasing greenhouse gases on urban infrastructure, particularly the transport modes encompassing road and rail. To conclude this discussion, we examined the critical problems of increasing climate change on urban transport. This discussion explored how the changing temperature, increased precipitation and flooding is impacting upon urban transport systems. These impacts are measured as directly caused by increasing greenhouse gases in the Earth's atmosphere and weather system. Thank you very much for listening.